sampling continued. This would be what, number 4 or 5. I really should label these and create groups. But sampling, what do you think about sampling? If you're going to sample something, you go to the grocery store and you get a sample of new cheese. Maybe it's tasty. Although that sampling has gotten rare with the COVID times, which is okay. It'll come back, maybe with a vengeance. So, sampling. When you get into the details of sampling, there are only 3 types. Well, we're going to go with 3 major types. I'm going to toss in a 4th one. We'll see where it goes, how long this lasts. So from a purely instrument perspective, you haven't chosen an instrument yet. You have to know what you're sampling. And there's only 3 types of sampling. Solid phase, liquid phase, gas phase. The way you sample to find out what your question or what your answer is find an instrument that could answer the question. So there are techniques here that it's easy to consider and think of. We'll start with a rock. Lehigh University is a noted place that studies rocks. Any mining university or school or college or community college is going to discuss rocks. What they are, how they are, the age of them, billions of years. And you have to understand those as facts more than concepts, because it's just how it works. Once you get down in that mine and you're considering the safety of how many miners, or $1 million worth of robots now, down in that mine shaft, you have to get air down to those people. If you have any type of oxygen burning diesel fuel, gasoline, propane, you have to get air for that equipment to run, or think of another way of doing it. Electricity, now you have to run electricity everywhere. So, rocks, sampling rocks. A geologist will go out in the field somewhere and dig up a rock. A geologist might go dig up a bone. A paleontologist might go dig up a bone. Many other ologists might dig up bones and make thoughts and prayers about them. You can do these things, but to find out some more of the details of that, you need a sample. So that bone sample is a solid object. That rock is a solid object. That carrot you want to sample is a solid object. But the carrot has a nuance. It outgasses. It has liquid which wants to evaporate. So you have to manage that sample a little bit different than other samples. I have water. Water evaporates. Whatever's in the water evaporates. What's in the water might settle. There's many measurements you can do on that water just from looking at it. You can do opacity measurements to see how much suspended solids are in the water. But we're not talking about that. We're talking about what the water actually is to the molecule and isotope. That's the question. Because we know and understand, we should know and understand that someone should know and understand about how that works. Because in that water can be many other molecules. Those molecules contain elements, and elements are a part of a series of isotopes that pretty well drive life around us. Thousands of them. It's awesome. It's freaking amazing. So, sampling. What does this have to do with sampling? I've got a rock. I've got a liquid. I've got a gas. I can freeze that gas. I can supercool that gas, get it to condense into a liquid, and then I can further freeze and condense that gas and get it into a solid phase. I might have a reason to do that, because the lower energy level they are at, when I excite them, that difference is going to make more things visible to the right instrument, not the wrong instrument. So this is isotope elemental identification. In order to know what you're trying to question, query, understand, you start with what you're trying to understand. So there's the sample piece of this. I'm speaking specifically to water sampling because I think that's the most critical story in human history. Drinking water for the planet. Drinking water cannot poison a population. That's wrong. It's a sin. It's a crime if we know about it. And people evaluate these things. Large institutions formed for these reasons evaluate these things, right? Knowing how they work to be able to trust them. So water samples, this is what I'm talking about. But how do we get it analyzed? Where do we get it analyzed? We're going to have a liquid. When you heat a liquid, it outgasses. If you boil a liquid, it outgasses. So you could, theoretically, depending on the heat that you can apply, analyze this as a liquid and get micro separations done using things called capillary columns. That's gas phase analysis. But the challenge with that is the specificity, how capable it is. It's very good in elemental in compound analysis, multiple elements tied together, but it doesn't necessarily identify the elements, the isotopes of the elements. It can say carbon-14, but it cannot say, well, it can say carbon, but it can't say 14, 16, 18, or 11-7. So understanding what that is. So where do you go to ask, how do you sample this? Where can we get this done? Who does this? How do we flow this? If you search at Google's, you will get water quality lab testing. That is not what we're looking for, unless it is a specific lab with specific certifications for doing this. So you've got this idea of these water samples and thousands of them needing to go somewhere, and you'd like it to be a few somewheres because you want to balance and test one somewhere against another somewhere, keeping them honest. This is part of an audit process. This is part of a certification process. A shop that's not getting the correct results wants to know about it, and will go find out why. If they don't, they lose business very quickly for rules and reasons. So, sampling. We're looking for, who do we ask to sample these? Universities, colleges, and institutions capable of doing that, which are in limited supply. So I actually dropped a few names in the beginning of the conversation unintentionally that may have community outreach programs that would talk to this conversation. This isn't a conversation, it is a conversation for states, but is also a conversation for the nation because pollution knows its own rules, the rules of the natural world.